Hey guys, so today we'll be going over lesson 6.3. Sorry, I have it backwards, by the way. In this lesson, we'll be going over second derivative and concavity and much more. And by the way, this is double prime of x, no, prime of x, excuse me, and double prime of x. And you'll see what this is all about in these two. Now, to start it off, what is dy over dx? Well, what it means is it's differentiating y with respect differentiate y with respect of x, and what respect of x means is you're using your x in your y equation. Now here I have demonstrations that x doesn't have to be only variable; it can be z, which 2 plus f of z is equal to 2 plus z, f of l equal to 2 plus l. It doesn't matter what variable you use, just as long as you use that specific variable. And you can't use two variables, otherwise it'll be no longer. For example, let's say we have z. If we put another variable in there in this equation, it will be no longer respect of z. Instead, it wouldn't be no longer respect of z. So anyway, continuing. A shortcut to finding the derivative. Now, I call this process differentiating, and this is a shortcut. This isn't the original version how to differentiate, but this is a shortcut to find the first derivative. So I have right here 2 times x to the power 2, and we would have to subtract the exponent by 1. So 2 minus 1 will give us 1, and we'll place the 2 next to the whole number, which would be 2 times 2 is equal to 4, which our first derivative, or prime of x, is equal to 4x. And here's just like the steps that I just explained, how to get the first derivative and how to differentiate. What is prime of x? Prime of x is we use to find our stationary points, and we only get stationary points when f of prime of x is equal to 0. In other words, when the slope of the tangent line is 0. So right here, I have in this graph right here that in this tangent line, its gradient is 0, and this tangent line, this gradient is 0. And if we look into in this graph, we can see that we have 2 tangent lines, but the gradients are different. They're not 0, which we can use as stationary points because the tangent line isn't 0. Now, what our stationary points is when the x-coordinates of the slope of the tangent line is 0. Now, continuing on. And again, I'm going to explain again how to find prime of x, or first derivative. And here I have f of x equal to 5 times x to the power 5. And we will subtract the exponent by 1. And we will have 5 minus 1, which is equal to 4. And place the 5 over here next to the 5, which 5 times 5 equals 25. And this will be our first derivative equation, which will be prime of x equal to 25 times x to the power 4. And here again, I have the steps that are written out that I just explained. This entire differentiating process to getting first derivative, or prime of x, whichever you prefer to call. Now, what is this? This is double prime of x, or second derivative, whichever you prefer to call. And this is just here explaining the double prime of x, which is your second derivative, which tells us the concavity of the original function. What is concavity? Concavity tells us the rate of decrease. Now I have a graph that the line goes up, then down, then up. And this part of the line, it represents a concave down, which rate of decreasing is increasing. Which from over here, the line is decreasing, decreasing, decreasing. And over here, we got a concave up, which rate of decrease is decreasing, which this line is increasing, increasing, and increasing. And then the way to figure it out that it's either concave down or concave up is that it's depending on the answer of our second derivative. If our second derivative gives us the answer of negative answer, then it's concave down. If the equation from a second derivative gives us a positive answer, it's concave up. how to find second derivative? Well, to find second derivative, it's the same process as finding the original function of finding the first derivative. So we have to differentiate. So here I got the first derivative, which is prime of x equal to 8 times x to the power 4 plus 3 times x to the power 2. And so what we would do is we would subtract the 4 minus by 1, which gives us 3. And we'll place the 4 next to 8, and it will give us 4 times 8 would give us 32. And over here we will subtract 2 minus by 1, which gives us 1 as our exponent, and place the 2 next to the 3, and 2 times 3 it would equal to 6, which gives us double prime of x equal to 32 times x to the power 3 plus 6x. And over here, again, this is the steps out of what I just explained, just in written format. And let's continue. Now, what is point of inflection? Point of inflection is where concavity changes from rise and up. And when do we get point of inflection? When the double prime of x is equal to 0. This is what it looks like, by the way. So let's say I have double prime of x, and our answer is 0. This is when we know that this is a point of inflection, which this is what it would look like. Not all the time, but most of the time. In which our dotted line would be between concave up and concave down. And let's continue forward. And so let's head off to the examples. Example 1, I have negative 2 times to the x to the power 3 plus 2 times x to the power 2 plus 6x. And we got 4 questions. First question is asking for the prime of x, or first derivative. 2 is finding the stationary points. 3 is finding the second derivative, or double prime of x. And 4 is what is the concavity. Now, heading off to question 1. We have f of x equal to negative 2 times x to the power 3 plus 2 times x to the power 2 plus 6 times x. And this is here that I wrote the equation again. With that, anyway, we will subtract 3 minus by 1, which gives us 2. And we will place the 3 next to the negative 2, which would be 3 times negative 2, and it gives us negative 6. And over here, we subtract 2 minus by 1, which gives us 1 as our exponent for x, and place the 2 next to the whole number 2, which 2 times 2 will give us 4, which gives us 4x. And then over here, we subtract the x's exponent minus by 1, which is 1 minus 1, which x is no longer there, and we multiply. We put 1 next to the 6, which would be 1 times 6. Sorry. And we will be left out with 6. Not 0.6, just 6. And this is, again, the steps again that show of the written format of how to do this. Differentiating. Anyway, continuing. Find the stationary points. Now, if you look at how the equation is set up, it looks like we can use it in quadratic format, which, if we plug in the numbers, we would have negative 4 plus or minus square root of 4 to the power 2 minus 4 times negative 6 times 6, all divided by 2 times negative 6. And if we square 4 to the power 2 and multiply negative 4 times negative 6 times 6, we should get 16 plus 144, square rooted, by the way. In which in total, and if we multiply 2 times negative 6, we should get negative 12, which we should get negative 4 plus or minus square root of 16 plus 144, all divided by negative 12. And if we add 16 plus 144, we get 160. In which our equation now is negative 4 plus or minus square root of 160, all divided by negative 12. Now, we split the equation into 2 parts, which in here we got negative 4 plus square root of 160, all divided by negative 12, which gives us, if you put in your calculator, negative 0.720. And we have the subtraction version, which we had negative 4 minus square root of 160, all divided by negative 12, which should give us 1 0.387. Question 3 asks, how do you find the double prime of x, or second derivative? Now here I got prime of x equal to negative 6x to the power 2 plus 4x plus 6. Now if we differentiate it again, which is the same process as finding the first derivative, we would subtract 2 minus 1, which gives us 1 as our exponent, and place the 2 next to negative 6, which would be 2 times negative 6 is equal to negative 12. And over here we got 4x, and we subtract x's exponent by 1, which is 1 minus 1, which leaves us with a variable, and multiply 4 by 1, which we place the 1 over here next to the 4, would be 1 times 4 equals 4. Now over here we have, let me make this clear, 6. And this time we don't have a variable, so we'll be multiplying 6 times x to the power 0, which will be subtracted by 1. And we place the 0 next to x, which would be 0 times 6 would be 0, times x to the power negative 1, which would give us 0, which is why 6 doesn't exist in our new equation, which double prime of x is equal to negative 12x plus 4. Now, fourth question. Finding the concavity. Now, since we already figured out our stationary points, we can implement them to our second derivative equation. Now here, we have double prime of negative 0.720 equal to negative 12 times negative 0.720 plus 4, which we should get 12.64 as our answer for double prime of x. Double prime of negative 0.720 equal to 12.64. And then we implemented the other stationary point of 1.38 into our second derivative equation, which double prime of 1.38 equal to negative 12 times 1.38 plus 4, which we should get an answer negative 12.56. Now, if we look at double prime of negative 0.720, it is concave down because of the answer given us. No, excuse me, it's concave up, which the answer is given us. And over here we got double prime of 1.38 is concave down because of the answer that's given us from the equation over here. Now heading on to example 2. Over here we got 12 times x to the power 4 plus 6 times x to the power 4, all divided by 4 times x to the power 2 plus 2 times x. Now question 1, we're trying to find the first derivative, and the second question we're trying to find the double prime of x, which is second derivative. Going through the first question, find the prime of x. Now over here we got 12 times x to the power 4 plus 6 times x to the power 4, all divided by 4 times x to the power 2 plus 2 times x. Now if we were to subtract 4 minus 2, which gives us 2, and divide 12 divided by 4, which gives us 3, and then 6 divided by 2, which gives us 6 divided by 2, it gives us 3, and then subtract 4 minus by 1, we would get 3. And if we rearrange them, which is these lines are showing that where I put these terms, which would be f of x equal to 3 times x to the power 3 plus 3 times x to the power 2. Now we're ready to differentiate. So we're going to subtract 3 minus 1, which gives us 2, and place the 3 next to the 3, which is 3 times 3 equals 9, which should give us 9 times x to the power 2. And over here, for 3x to the power 2, we can subtract 2 minus 1, which gives us 1 as our exponent. And then place the 2 next to the 3, which 2 times 3 gives us 6. As our first derivative, we will have prime of x is equal to 9 times x to the power 2 plus 6 x. Heading off to our second question, find double prime of x. Over here we got prime of x equal to, the prime of x equal to 9 times x to the power 2 plus 6x. Now we will subtract 2 minus 1, which would be 1 over here, and place the 2 next to 9, which 2 times 9 will give us 18, which will have this as 18 times x. Now here we have 1 minus 1, which gives us x, which leaves us without a variable, and we place the 1 over here, which is 1 times x. 6, excuse me, and it gives us our answer as 6, and it leaves us with our second derivative, which is double prime of x equal to 18 times x plus 6. Now over here, I have IB questions that you can do it for your homework, which is this is kind of as 5 points, and we have 36 times x to the power 3 plus 12 times x to the power 2 minus 8x. First question, 1a is asking, find the first derivative, and our answer is prime of x equal to 108 times x to the power 2 plus 24 times x minus 8. B is asking, find the stationary points, which our answer is x is equal to 0.18, and the other one, x is equal to negative 0.40. Now, I have another question, which is another question, which you can't use a calculator in this question. Question 2, this is validated as 3 points. Question 2a, find the second derivative, and the answer is double prime of x equal to 32 times x plus 6. Now 2b is find out which stationary point gives us a negative concavity, which the answer is x is equal to negative 3 over 8. That's it for today's lesson. Thank you for staying tuned. Hope this helps, and whatever. Hope you're doing great in math, and wish you luck.